So our next speaker is Professor Sarit Kraus from Ilan University, who will tell us about computer agents that interact proficiently with people. Please.
Thank you. So I like to develop and research and study agents. And I'm lucky that Sarah talked about before me, so you know now what is agents. They are not this agent, no FBI agent, but intelligent computer system that are autonomous, know how to plan, adaptive, able to learn. But I'm especially interested in agents that cooperate with other agents or people. And if robots are in the environment, I'm even happier. So what these agents can do? The agent can support people, they can replace people, and they can be used for training people. Why won't you get in? And I will continue. No, we started exactly at the time. This was a mistake. Okay, supporting people. So I had a project with General Motors where we try to support the driver in electrical car, how to set the climate control system so it will feel comfortable, but will save energy, because the climate control system, the air conditioning, takes the most energy after the gas in electrical car. And the recent project was an agent that tries to understand a passenger in autonomous car, so the car will drive according to the passenger's preferences. You know, when I drive with when I'm the passenger, my husband driving, and I tell him, be careful. He understands exactly what I mean. So people are not comfortable in autonomous cars because of this reason. And all project running in LAX, in Los Angeles Airport, since 2007, where the autonomous the agent helps the security people in the LAX airport in setting random checkpoints in the airport. And recent project with the Israeli police, where to put checkpoints and where to put cruisers, police cars in the roads in order to reduce car accidents. They tried it in the Shfela area, and it was really helpful. But another project with another domain is an agent that helps in emergency rooms, distributing people to doctors and other professionals. But autonomous agent can also replace people. We had a project where we developed agents that try to convince people to change their mind. In the experiments, we asked a student a week in advance, what do they want, a cake or a bar? And if they asked, and then they came to the lab a week after, if they said they want a cake, the agent tried to convince them to take the bar, and the other way around, and at the end of the experiment, they left the lab with the cake or the bar. The agent did quite well, at least as well as people, but it's very difficult to change people's decisions. We had another project where we developed with Shiba a automated speech therapist that is used by even Kupat Cholim. The medical insurance gives pay for it for people for rehabilitation, for brain damage patient to train from home. And training, we also have agents that are used for training people in employer-employee situation. You know, before you go to discuss and to bargain about job condition. You can come to our agent. He can play either the employer or the employee using chat. You can negotiate with him about pension and other things, and you can use it for training. Talking about training, we also have a project with Horizon 2020, LawTrain, that we develop agents that can be used for training a team of law enforcement personnel in joint investigation, where we develop an agent that can play the role of a witness or criminal, somebody that they want to interview, and he plays the role of the person. Okay, so I just gave many, I can keep on telling you about, I'm doing it for 30 years, so I have many applications, but the question is, what is common to all these agents? What is common to all these systems? So in all these systems and in all these applications, the main thing is that the agent need to predict the person, the people decision-making. In negotiation, it needs to predict whether the person will accept the offer that is made. In the car, they want to predict what will be the preference of the passenger in a given situation. If we are moving to the automated speech therapist, what the human speech therapist will do in a situation, and we'd like the agent to do similar actions, and how the patient will respond. This speech therapist gives advice to and clues to the brain damaged person, how will the person respond. And in the suspect, you need to predict what the suspect will say in a given situation, and so on and so forth. The problem is that I always say people are really annoying. They always ruin my experiments, I'm telling you. But, okay, they don't maximize expected utility, if I will be exact. Okay, why? Because they are sensitive to context, they lack knowledge of their own preferences, they are affected by complexity, they have interplay between emotion and cognition. I don't know, I don't understand in people, but when I'm trying to predict their actions, it's very difficult. Even I look at myself, and suppose I'm playing some game for the experiments, in a similar situation, I may make different decisions, and this gives a lot of noise into the data. So over the years, we develop a methodology of how to overcome this problem. So we always start with some data. The problem is that while pictures, there are many examples, usually, but decision-making of people, it's much more difficult to collect data on. I'm waiting. Over the years, we are collecting, but it's very difficult. So if possible, in order to do good feature selection and feature development, we are trying to use human behavior models, models that were developed over the years by psychologists, by others. The problem is that these can give us only features. It doesn't give us the exact formal way where how people are working. So data, we have, of course, machine learning methods, and we are developing human prediction model. And then if we have data on specific person, like the specific passenger in the car, like the specific patient, we are entering his data and combining it into the general model that we'll build. But prediction is only the first step in building agents. Eventually, the agent has some optimization problem to solve. In the car, it would like to minimize the energy consumption. In the car accidents, he would like to reduce the car accidents. And the main question is, how do we integrate the human prediction model into the optimization problem of the agent? And if we have adversary, as in the airport, we would like to integrate it into the game theory model that we used when modeling also adversary. So we need always to remember that prediction doesn't give me anything if I can't integrate it into the optimization problem. And then once the agent solves the optimization problem, he is choosing the action to take, is taking the actions. If there is a good way, nice, virtual something, virtual human that, or nice robot that is interacting with the person, it's always helpful. And another helpful thing that we are doing recently is to have a way to explain the decision making of the agent. And explainable AI is now very common, very top, but we are not interested just in understanding the black box of the machine learning. We would like to take a larger picture and understanding the overall decision making of the agent, so it will interact well with the people. So data, machine learning, and optimization methods. So this is the general idea, the general methodology. I would like to talk about two specific examples. So the first work I want to talk is about reciprocal recommendation system. And what is reciprocal recommendation system? So think about dating. Okay? When Amazon recommends a book to a customer, it needs to find the best, the most appropriate book for this buyer, customer. However, for example, in dating, if I will give the most wonderful woman to this guy, if she doesn't want him, it didn't help. The fact that she is the best for him. In reciprocal recommendation, you need to find a recommendation that will be good to both sides. Or, for example, if I am talking about employer-employee, I am recommending a young student to go and work, to do a postdoc. We are having postdocs, so I could have sent her to Harvard, recommend her to go to Harvard because they wanted her. But if the student is not that good, then I need to find a place where both sides will be interested. So this is the problematic of reciprocal recommendation. And I have Akiva, this is a student that initiated the project. I must tell you, he really wanted to get married. And he thought working about dating maybe will improve his chances. Well, he finished the master's. He had 2 papers in Rec6, which is the most prestigious conference in recommendation system, but he's still not married. Okay, so the problem in this kind of recommendation system is that the agent has an optimization problem to solve. And he should, in this optimization problem, he needs to balance between the users that he provided with a service, the users that provide the service, and the recommended users. and how should the agent balance between these two things. So data, machine learning, optimization method, let's say how Akiva did it here. So the optimization problem is to find the best recommendation that will lead for interaction, not the best recommendation that the person that I give the recommendation will accept, but the one that will lead to interaction. Interaction, the customer will send the message to the other side, and the other side will respond and start an interaction. So from the machine learning problem, we have two questions. One, the user that we're providing with a service, can we estimate his preferences? And we are doing it with collaborative filtering, which is the most common way to find preferences and to recommend to people in the morning. There was another person in the early afternoon that talked about recommendation, and collaborative filtering is the most preferred way. Okay, on the other hand, we have a prediction problem, which is whether if our user will send a message to the lady, will she respond or not? This is a prediction problem, and we would like to, we use adaptive boosting prediction because it's a minority case in order to predict this. And then we have another problem is how to weight between the collaborative filtering model and the prediction model. And it turned out that this is the optimization problem, and we should do it personalized. We need to find for each person what will be the weights that we need to put on the how much he likes and who likes him. So data, we collected data. You know, Akiva is really amazing. He was able to convince a real site of a dating site to give him the data, and then later also to try his algorithms. And so we collected first a lot of data about messaging and the messages that were sent back, and we developed prediction. We also collected data about each specific user's past interactions, and we used the collaborative filtering to build the model and to personalize the score. Also, we learned from this data. So in general, you have Bob. You generate for him possible recommendation using collaborative filtering. You also predict whether the other side will answer. You have aggregation by weights that, again, we learned, and then we send the recommendation. We did it on a real site. We ran experiments. We compared between the successful interactions that they used before our system and the ones that we got. You see, it's really improves their behavior. Interestingly, and maybe not politically correct, is the weights for the women and the men that we learned were different. You can see that women were more interested, you know, it was more important to give them recommendations that are best for them, the collaborative filtering part. On the other hand, for the males, in order to make this interaction, it was more important to look on the other side, on the prediction of the other side. And then we also added explanation. Again, the research question was whether we need to use reciprocal explanation or one-sided explanation, what I need to explain to you, both sides or one side. And again, we tried both, and you can see that in all the cases, reciprocal recommendation was better, but males and females, they had different preferences, and this is another example that you need to be very personalized and to use the data to do prediction, and then do the optimization problem. So this was one example. I would like to, I have still 5 minutes, to give another example, which I really like. Robots, drones, they are cars. They are mainly autonomous these days. However, in most applications, there are still here firefighters, 2 firefighters on 1 drone. You know, any drones, they usually, these robots, firefighter, 1 robot. And the question is, first, why? Why do you need a person in the loop? And the other thing that you want to ask, why 1 person can manage 10 drones? You know, there are many autonomous. What do you need the person? So first, why you need the person? Because of 3 reasons. 1, if something goes wrong. 2, because the owner of the drones and the UVAs, etc., don't like, you know, mazlat, they don't like the robots to be fully autonomous. They want to leave some of the decision to the person. You can think about various domains, but this is the case. And also, there are some actions that people do better than the robot. Even, you know, I have these small robots in the lab. They can, you know, they can get into the ladies' room, and then, you know, in general, they can go out. But if you are, you know, if a person teleoperates them and goes them out of the small space, it's much faster. So people are good for, if something goes wrong, for making decision in a acute situation, and when they are better. Okay, fine. So you need a person. But why can't 1 person manages 10, 20 robots? Because people are getting overwhelmed by the robots. And then we said, okay, what can we do? So we suggested to add agents that will help the person and the robot. And we used our methodology. We have data. We build model for the robots and the humans. Again, collecting data on humans was quite challenging because, you know, we had to bring humans to deal with the robots in order that we'll be able to work with them. And we had machine learning. We have the optimization problem. What's the advice to give to the person, to the operator, so the overall performance of the robot and the operator will be good. And we did it with 10 robots and 1 person. In all the cases, people that got help by an agent did extremely better, not them, with the robots, than without the agent. So this is the case. On average, we have 7 goals. They looked for yellow balls, 7 without the agent, 14 on average with the agent. So let me summarize by showing you, if I will be able to, how do I, okay. Let me show you a movie that summarizes this project.
Dispatch.
Quick! There's a student missing in the northern section of the campus.
Give me the exact location. A unit is on its way.
In disaster environments, both the victims and the rescuers' lives may be in danger. Robot technology can provide solutions. Today's robots are semi-autonomous and require a human operator's help whenever they cannot handle the situation on their own.
Move Agent 3 away from Agent 4. Move Agent 4 away from Agent 5. Manually drive Robot 6 to a better...
The fast-paced, simultaneous streams of data from multiple robots can be overwhelming and can be a grueling task for a single operator.
Your robots are too close together. Spread them around. Your robots are too close together. Spread them around. Manually drive Robot 6 to a better position. Move Agent 3 away from Agent 4.
Here in Ilan University, we have developed an intelligent agent that supports the human multi-robot team collaboration. The agent prioritizes the different tasks, filters the robot's signals, and generates warnings which enhance the operator's situation awareness, thereby allowing him to make better decisions. The agent uses a novel methodology combining machine learning and optimization techniques, which accounts for both the operator's abilities and the robot's performance in real time. Through extensive empirical evaluations, we have shown that our agent was able to significantly enhance the team's performance, which can translate into saving lives.
There he is. We found him. We got him. I'm sending you the exact location now. Dispatch out.
So in this talk, I gave you examples of agents that can support people, replace people, be used for training people, using data, machine learning, and optimization problems. And if you have a problem where agent can help, please come to me. Thank you.
Thank you. Questions? Okay, so thank you again.